And welcome students as we continue diving into the ArrayList class. All right, we're going to today look at an ArrayList example. So that example, of course, is going to be that of golf scores. We actually seen this class before, and I'll talk about that later, back all the way in Programming 1 when we dealt with arrays. But the program golf scores, for our purposes, is going to read in a list of golf scores and then output the average of the scores and how much each differs from the average. The scores are read and stored into an array list so that they will be available later in the program to be output along with how much each differs from the average. This is the kind of thing that's well suited to be done with an ordinary array. Like I mentioned, we did this back in Programming 1. However, it's much easier and cleaner to use an array list as we are going to do in golf scores now. So, our program in golf scores is going to deal with a list of values of type double. But we can use an array list with base type double, notice a capital D, so it's a wrapper class, to store these values. We did not use an array list with base type double because, again, there's no such thing. You don't use primitive types with array lists. The base type for an array list must be a class type or some other reference type. However, thanks to Java's automatic boxing, we can program as if an object of type array list double can store the values of type double. The array list automatically keeps track of how many elements are stored in the array list. If we had used an ordinary partially filled array in our program instead of an array list, we would need an extra int variable to keep track of how much of the array is used. And when we use an array list, we are spared all of that overhead associated with partially filled arrays. Remember, partially filled arrays, if you remember from Programming 1, was kind of messy. There's a lot of things you had to juggle around. Now, the beautiful thing with the array list is that these details are taken care of for us automatically. The code for those details is in the definition of the array list class, but there's no need to look at that code. The code is all the implementation detail that we need not worry about when using the array list. Again, very nicely handled. Now, notice there will be use a for loop. So in order to show you, I'm going to show you this right here. You'll see here's our class right here. We have a couple for loops in here, but you'll notice that this is not a regular for loop. It is a for each loop. The cleanest and easy way to cycle through all the elements in an array list is to use a for each loop. Boom, here it is, for each. For double element in A, total equals total plus element. It is instructive to compare the program golf scores, which uses an array list, with the program golf scores back from Programming 1, which does the same thing, but it was using just an ordinary array. The version that uses array list is much cleaner, even much shorter than the one that uses an ordinary array. It's because array list does so many things for you automatically, normally you'd have to explicitly code if you use an ordinary array. So this is a great example here looking at things such as information hiding and also code reuse. The programmers who defined the array list class did a lot of programming for us so that our programming would be simpler than others would have to be. All right, before I get to talk about trim size for memory, let's just quickly compare these two programs here, just so you can kind of see how much cleaner array list version of golf scores is compared to the ordinary array list. All right, so here I have, of course, the new version, and here's our older version. You can, of course, here's that integer to keep track of things. And of course, they do the same thing. This is going to keep a list of golf scores and their average. So here's the program, our main method. Here's our main method. Here's our fill array method. You can see even this is a little bit simpler in task than the other one, simply because it's just a list, array list that we have to do rather than having to deal with the array. All right. Then, of course, we have our compute average down here, which is right here. You can see that is not drastically more complex. If anything, this might be just a little bit longer, but it's not too terrible. And then, of course, we have our show difference. But where you see the real return, of course, is here in the fill array. Whereas here, it's just, well, next is greater than or equal to 0, a.add next is equal to next double. Whereas here, I have to make sure it's between the starting value and the length of it, because I don't want it to have like a array out of bounds error. So it does make things a lot simpler when you're comparing between the array list version and the array. All right, so using trim to size in order to save memory. Array lists automatically increase their capacity when your program needs to have them have additional capacity. However, the capacity may increase beyond what your program technically requires. Also, when your program needs less capacity in ArrayList, the ArrayList does not automatically shrink. It doesn't get smaller by itself. So, if your ArrayList has a large amount of excess capacity, you can actually save memory by using the method trim to size in order to shrink the capacity of an ArrayList. So let's say it was you set it to 100, but you need to shrink it down to 20. You can use that trim to size. Now, if a list is an ArrayList, the invocation of list.trim to size will shrink the capacity of the ArrayList list down to the size of list, so that way there is no unused capacity in the list. Normally, you should use trim to size only when you know that the ArrayList will not need its extra capacity later. All right, now quick pitfalls for you. First one is that the clone method makes a shallow copy. There are situations in which you would like to make an independent copy of an ArrayList object. That is, you'd like to make a deep copy of the ArrayList object. For example, if you define a class with a private instance variable of an ArrayList type, then you would like an accessor method to return a deep copy of the ArrayList stored in the private instance variable. The reason you want a deep copy is the same as the reason that you want a deep copy of an array instance variable. It would be a good idea to kind of review the subsection where we talked about clone method and deep copies before really kind of going on and talking about the rest of the stuff here. So if you need a refresher about the clone, look back in your notes from Programming 2 where we talked about the clone method. We talked about shallow and deep copies, because that could be a good refresher for you. I'm not going to kind of go over it again here. Just know that that is a good thing to know because of what happens with array lists. All right, so as we've often have reserved, the assignment operator merely copies a reference so you have another name for the object being copied. So you do not actually have an independent copy. You have what's known as a shallow copy rather than a deep copy. So for example, assume that pet is a class with the usual kinds of accessor methods and consider the following code. ArrayList pet, petlist1 equals new ArrayList pet. Some code to set the instance variables of the elements of petlist1. ArrayList pet, petlist2 equals petlist1. Petlist2 and petlist1, in this case, are just two names for the same ArrayList object, right? Because we pretty much just cloned it. Now, making a change to petlist1 in this case, or to an element of petlist1, will also change petlist2 because they are the same list. So very important that you kind of keep this in mind. You can't just, I'm just going to say equals this. Right? Doesn't quite work like that. Now, if you want an independent copy, or what's known as a deep copy of petlist1, you might think the following would give you your independent copy. Array pet, petlist2 equals petlist1.clone. So, hey, I'm going to use the clone method. Beautiful, right? Well, unfortunately, the clone method also will make a shallow copy with the ArrayList class. There's no really built-in method to give you a deep copy or an independent copy of an array list. When you need a deep copy of an array list, you'll have to resort to some ad hoc tricks. So it's not going to be something that's going to be kind of clean and easy to do. If you have a way to make a deep copy of the objects of the base type, then you can create a deep copy of each element of the array list and then place them into a new array list object. This is pretty much the exact same approach that we discussed when we want to make a deep copy of an ordinary array. Right? So you pretty much have to make a second array, transfer this up over, blah, blah. All right, it's not going to be simple as a .clone or, hey, array equal this other array, or array list equal this other list. It doesn't quite work like that because, again, those are only shallow copies. Now, the situation with respect to deep copying on array list is the same as the situation with respect to deep copying that of an ordinary array, as we kind of have just mentioned. Although the details of this lesson kind of seem very subtle and maybe even difficult for you to wrap your mind around, just remember, these aren't new. We have dealt with these kind of things before, even all the way back in Programming 1, we dealt with arrays. So it's just simply just applying that knowledge that we already know into a new manner. All right, and like I said, we already applied this all the way back with ordinary arrays. All right, and that's it for today, folks. So that was just an example of an array list to kind of help solidify a little bit more of what we've been doing. So with that being said, I will see you next time.